On problem 610, you have a half a kilogram block that slides across the tabletop. The initial velocity is 20 centimeters per second, and it comes to rest at after sliding a distance of 70 centimeters. It says to find the average frictional force that is causing it to slow down. If we start with our traditional conservation of energy equation, initial potential energy plus initial kinetic plus work equals final potential energy plus final kinetic. What you can do is because the block is on a level surface both before and after the well, at the beginning and end of the problem, you can say that the initial and final potential energy are zero. You also can use 1/2 mv squared for the initial kinetic energy here, and for the final potential energy, final kinetic energy, you could say that that is also zero. So essentially what you're doing is you're going to get that the work is equal to the negative change, or the negative of the initial kinetic energy. We'll see if that's what they did in the problem. They go about it slightly different, but here is the work, where there's the frictional force times distance times the cosine. So the work is force times distance times cosine. The torque, which is in chapter 5, was force times, I guess, lever arm times the sine of the angle between those two. But this is different. This is work. So force times distance times cosine of the angle. I guess at some point they're going to tell us that the final velocity right here is 0, and that the angle here is 180 degrees because the angle between force and the displacement is 180. They're opposite of each other. The object is moving this way, but the retarding force is in that direction. So that's why that's 180. And so you get a minus sign there. This also has a minus sign right there. They do tell you here that the final is 0. So there's a minus sign, there's a minus sign, and you're able to find that the average frictional force is 1/2 mv squared divided by the distance. Notice that they changed it to the MKS system. Remove the centimeters here and remove the centimeters there in their solution.